Okay, so this is kind of a pre-pressure notes before you watch the pressure notes. And I just want to get a couple concepts through. And so this is a program called PHET.net, and they have a lot of really good science labs. And so this is really looking at pressure. We have pressure gauges here with depth. So we start at the surface and going down 3 meters. So this is kind of like when you're going into that swimming pool that I'll talk about coming up. And what happens as the water increases, what happens to the pressure the farther into the water you go. So let's fill this up. All right, if we fill it all the way up to the top, we can look and we can see up here in the atmosphere, 101.303, and you can actually see even in the atmosphere that the pressure increases the closer to the surface we go. And when you're underwater, and if I put this here right under at the surface, okay, we can see that from here at 0 meters to 1 meter, we've increased by 10 kilopascals. And pascals is a pressure unit, just so you know. I could also change that unit to atmospheres. So this would be like 1 atmosphere. This is 1.1 atmosphere. So that's what we feel compared to what our normal atmosphere is. And if we wanted to go into English, that 4-letter word we usually try not to talk about, this would be like 14.7 pounds of pressure per square inch. A meter 3 feet down would be 16 pounds roughly per square inch. A little over 6.5 feet down would be almost 17.6 pounds per square inch. And if we went all the way down to 10 feet, we've increased by 4 pounds per square inch than our body. So when we feel that, we actually feel the difference in pressure. Now, normally I wouldn't do this in US standard English measurements, but it does help you understand that even as we go up here, the pressure, even with a little bit of change of distance and altitude, is going to make a difference in how much stuff is packed around us, because the farther down we are, the more stuff there is on top of us. So if I'm way down here, I have all of this water, 10 feet of water, plus the entire atmosphere up to outer space, all pressing down on me. And we can see this difference from surface, 14.7 pounds per square inch, all the way to 10 feet below the water. We're going up to almost 19 pounds per square inch.